This podcast is supported by Siemens, your partner for industrial-grade AI.
Hello everybody and welcome to a new episode of our Industrial AI podcast. My name is Robert Weber and it's a pleasure to talk to
Peter Sieber. Good morning, Robert. Good morning, evening, afternoon to you, dear listener, wherever you are.
Good morning, Peter. I am ready for a holiday.
Oh, are you?
Yes. I'm recording an interesting episode with Vogt Ultrasonic today and then I'm off.
Oh, really?
I need a break. Yeah, we will have a summer break. Yeah.
This is our final news recording that we're doing.
Exactly. This is the final news recording before our summer break.
Good. Deserved. Yeah. I mean, we being based in Germany, the way it works here is that there's a couple of parts of the country. The north typically has already gone into the summer holidays, and that's probably very similar with many of you, dear listeners, from other parts of the world. But this is the typical time for us where we live.
You have already been on holiday, so you can share some news.
Cool. We call that mobile working, Robert.
Exactly.
It's very modern working. Wherever you are, that's always the good thing and the bad thing. Wherever your notebook is, that as long as you're there as well, you can work or not work.
Exactly. So you worked a lot. So share some news with us, Peter.
Yeah, I'm going to share a couple of quotes with you today, but I'm going to start with maybe a couple of acronyms as well. I'm not sure. The first one is the ONNX. We call that one.
Onyx. We had an episode on that.
Yeah, it's going to be a combination of Onyx. I think that's the way you pronounce it in the end. According to Matias Lechner, he's a co-founder, CTO of Liquid AI. By the way, that's a startup founded 2 years ago. And he raised a Series A at 2.3 billion. So 1, 2, 3 words about him later. But he says Onyx is making a comeback in the LLM era. So Onyx stands for Open Neural Network Exchange. Yes, we discussed it with Fabian from Fabian Backhoff a while back. Not sure. Did I do that? Did you do that?
I did it, and he's engaged in this initiative, I think.
He's very strong. Yeah. So maybe he's going to give us an update when we're back from Audi Day at some point in time. But it's an open format, lets AI models run seamlessly across different frameworks and hardware, right? And I think that's what we understood from Fabian as well. And Matias says, think of it as the universal language for AI deployment. Now, according to him, for years, Onyx dominated computer vision, traditional ML, but when large language models arrived, he says newer stacks. I'm not going to go to the details. It's too technical for me and for many of you. And those of you listeners who are a lot more technical, it's great to have you with us and you know where to go anyway. Now, why is that? He says, again, for a couple of other technical reasons that I do not get into, but in the end, he says, Onyx is catching up fast again. One format to rule them all from cloud to S. So, question to you. Are you aware, dear listener, you, Robert, do you agree? Onyx in industrial. And as I suggested, maybe we should talk again to Fabian, but also happy to hear from any of you. Let us know. Happy to talk.
But I thought it was never gone. So when it comes to industrial AI applications. So
there you go. That's then a different view, maybe. Matias says there have been other specific ones which I can. What did he say? He said Llama, CPP, and XPtorch. So that's immediately for the guys like the Julians and thousands of others of you who know. He thought it had been gone, but now it's catching up again. So maybe we will chat with Fabian, but also others of you, if you have experience within the industrial setting with Onyx. Is it helping you? Has it been gone? Maybe not, as Robert suggests.
Perfect. So invitation to Fabian, greetings to Ferl. What else do you have, Peter?
Another quote, small is beautiful. That's related to, as an addendum, like the Matias post, because his Liquid AI LFM2 language model is specifically designed for edge. And not only his, I know another company or two, as well, Robert, being very strong in exactly this specific market segment, now deployed to be deployed on device, smartphones,
Exactly.
laptops, vehicles, whatever, and available on Hugging Face. And mentioning Hugging Face, this morning I saw a post also on Tiny Agents framework from Hugging Face. Again, the small is beautiful. And there's a third one, which is this paper from NVIDIA. It says small language models. They call them SLMs. The LLMs, we know the first L stands for the large, so the S for the small, are sufficiently powerful, inherently more suitable, necessarily more economical, etc., 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 for the future of agentic AI. And the thought is, I guess, and I'm not sure how far that is new or we've had all of this before. I mean, if I'm going to talk about like black boxes, they don't do that. So maybe that's wrong. But nevertheless, think of thousands, millions of small black boxes that are very, very capable of doing something very specific. In the past, it is easy as maybe as pieces of an operating system. And then Jakub has been talking about the LLMs as the operating system. Other people have, not everybody has agreed, but there you go. And if there's going to be millions of these pieces doing something very specific, they're very good, and call them agents, right? And there's going to be a smart agent at the very, very top who's going to find its way through all of these black boxes, which are then, and that's my understanding, without having read the paper. So if you hear that I'm saying bullshit, then let me know. But that's what I understand the idea is behind it. So if you want to have millions of these agents, they don't have to be, what is the big ones these days? 100 billion? Are they in the trillion? Whatever they are.
Yeah.
So maybe then it's enough for them to be in a couple of 100 million size, or even smaller than that. I don't know the exact sizes. And at least I can understand very well where they're coming from. So small is beautiful.
And there was a tech report by Apple, right? So
same.
And same. And the core is a 3B parameter LLM for an on-device use. I will share the paper in the show notes. It's very interesting. So the core is a 3B LLM. So it's a very small LLM.
Yeah, and maybe it's still bigger than I believe what the ones they're talking about. And I know of NXAI who's been moving to what the biggest was 7B, and then I recall the question we had in the Siemens conference where we were. The question: are you going to go bigger? Not for a moment, because that's exactly the market they are in as well. And my feeling is that these companies are even saying, it's perfectly okay within agentic, to use the word, it's not my word, but if we use agents, then it seems to be perfectly okay, probably, I believe, to go even below that, go below a billion, whatever.
Perfect. What else do you have?
Do you have something as well?
I have something as well. I have an announcement, because we already discussed our visit to Amsterdam, and now Stratis Gaffers from the University of Amsterdam shared some dates, and he invited us on the 21st of January to the 22nd of January to Amsterdam. We will do a 1.5 day workshop with the University of Amsterdam. So now it's official. And we invite all our listeners. We have 10 places to take part. If you want to take part, give us a message, and we will then inform you if you are able to join our session in Amsterdam.
Half of them are filled, I believe.
Yeah, half of them are already filled. Yeah, sorry for that.
Yeah, looking forward to it. It's great.
Yep.
And then there was this, I'm not sure who was the writer of the post yesterday, of a person being very proud of, but then, of course, yes, and I must say, not everybody, but I hear many, many times Zurich, and we're going to come back to you in a moment, Robert, and ask you to reshare with us what the top 10 by Sepp Hochreiter was. Just so
this was...
So give me a sec.
Yeah.
So give me a sec.
Yeah.
Yes, and maybe you're going to just destroy what I'm saying now. But I'm just seeing many times from Europe. I see Zurich. Is there any place? Is not sure. And then this one was very specifically about Amsterdam as one of the top cities. And then of course there was Paris as well, with the Hugging Face and the LLMs. And, and then that was yesterday, and then it was like, so why are we going to Amsterdam? Because that's Peter's
hometown,
country favorite city. No, it's not. It's because yes, they have really something to deliver and share with us. So remind us again, is that a year ago, 2 years ago?
No, it's when you asked 3 years ago, and
maybe after this changed, but
after this, we published this episode. We had a big shitstorm.
So maybe you're not going to repeat.
I think number one was Zurich. Number two was number one was Zurich. Number two was Amsterdam. Number three was Linz, I think. Number four was a university in USA. Okay. And there was a huge discussion because Munich was missing in the top 10. And you remember the discussions we had after this episode. Yes. But we will visit Amsterdam. It's the AI
powerhouse. At least we mentioned Munich now, right?
Yeah, because there are a lot of companies investing in Amsterdam. So we have a lot of startups like Cusp AI from Max Welling. We have a Bosch there. Booking is over there. Then is Qualcomm Labs are in Amsterdam. So there's a lot going on in Amsterdam when it comes to AI, right?
Yeah. Okay. Very good. And they were, of course, at that time, Zepp's personal opinion. Maybe you can check with him at some point in time if that's.
No, we won't do it again.
Okay. Maybe we better not. Okay. I've got a very quick one here. Yep. Another new acronym. Our friend Oliver Nigemann. We haven't heard from him for some time. He's a prof at the University of the Armed Forces in Hamburg, not the one where I'm close to here, close to Munich. And he introduces what he calls, or what is called, I'd never heard of it, inverse reinforcement learning. He asks, how can it be determined whether an autonomous system is still pursuing its intended goals? Right? And that's what he uses inverse reinforcement learning for. I can't go into the details because I don't know, but I just wanted to share quickly at that top level. It's like, normally you say reinforcement learning, give the system a goal and it shall go to whatever, win chess, or as we all remember, Jan Kutnik telling us 5 years ago, tell the algorithm to design the production line for you in such a way that optimize the number of coffee cups that come out every hour, and then it will do that for you. And in this case, it's like, the question is like, how can we, maybe humans, determine whether the system is still following the goal that I gave it? Right? And then I think it's inversing the direction such that you should then come out and say, like, what is your intended goal? And using the inverse reinforcement learning, it should then be saying, okay, well, you told me to optimize the total number of coffee cups I should produce. So that's all on it for those of you that are interested in.
So we should record an episode with Oliver.
Sure. Yeah. Looking forward to. Let's do that. Oh, there's a second one already for after the summer.
Oh, perfect.
Maybe I should still contact him today. So because you already have one fix as the first one after.
Yeah, I recorded an episode with Victor Schmidt from Paris. And Victor is doing something very special. He's using AI to find new materials. That sounds a little bit like what Max Welling is doing, but it's a bit different and it's very interesting. He's based in the Station F. This is a big startup area in Paris. And he shares why he moved from Montreal, from Bengio, Mila, to Paris. And now what's going on in Paris, and why is Paris such a big place for AI, or for industrial AI also in Paris. And yeah, it's a very interesting episode. I think it's the first episode after our summer break with Victor Schmidt.
That's where we schedule it. Yeah, right.
Yeah.
Okay,
Perfect.
sounds great. Yeah, sure. There's a big Canada, France connection, just from a language perspective. I
Yeah,
still have
but
to.
I also ask him why he didn't go to Berlin or to, I don't know, to Munich or something like that. Yeah, he will explain it in our
Yeah,
podcast.
looking forward to it. I still have 2-3 things, if I may.
Sure.
So there's a renewed discussion on the topic that Andrew Wang introduced some months ago, which I thought very interesting. And that, for once, I agreed with him again. I had a couple of times I disagreed with him. You recall maybe there was about the ratio shift between the headcount of product managers and engineers.
Yeah.
The quote was, I don't see product management work becoming faster at the same speed as engineering. So he says, product manager is the new bottleneck. Now, again, there's discussion very specifically. A manager says, my guys, my people, they come to me and they suggest that we're going to move from 1 to 4 to 1 to a half, one slower. It is going to be the same as if until today they had been working 2 product managers and they would have 8 engineers or coders, right? That has been the case in this specific case. That was the case, and they're gonna be changing it to 2 PMs for 1 engineer. Think of that. So you're going to keep the PMs the same, which would mean, and that's not the idea, but you're going to need to let go 8 engineers. Of course, that's the other huge discussion, that some managers are using AI for exactly that reason, so they can throw out people. Now, that's one thing. I'm not at the moment going to go into that discussion. The other way is to just to maximize, to do more things with help of AI. So that would mean if you keep then the true engineers, is that right? What I'm saying, 2 PMs to the 8 engineers, but you're gonna have to increase the PMs, and I think it's very strongly to what I've been saying in the past is like, give more responsibility to domain experts, right? So It's like, if you give this technology, this tool, I'm going to come to at the very end what it really is. Is it a tool? Is it more like a tool, artificial intelligence? And you're gonna give people like domain experts these tools, like maybe they are product managers, then they can build more these days than what they could in the past. In the past, it was a typical thing. I have asked let's give the example of IT. Sorry, guys, those people are in IT. I've asked you, 100 times if you could do this, but your answer was always, I have no time. I'm very sorry, I have no time. And then I started looking myself, but the technology was too complex. These days, if I, as a domain expert, and maybe I call myself something like a product manager or something close to a product manager, then I'm going to be able to do things a lot quicker myself. So I'm interested in your experience. Have you heard, Robert, in your experience, dear listener, is the same happening within your environments? Are you saying we have new projects and now we are seeing suddenly more people with the function of product manager relatively to less people doing the coding or doing the engineering? That's
interesting. Yeah, that's interesting.
Right. I have 2 more acronyms.
One more, Peter.
Okay, I'll do this. Yeah. It's a quote from Dina Shakir. She's with the Lux Capital. She says the future isn't C3PO, it's RTD2.
What?
I say one more. Have you not heard of C3PO and R2D2?
Yeah, that's
That's you're close to it. Yeah.
The movie.
Yeah.
Oh.
C3PO is the golden. He looks gold. He's a humanoid robot in Star Wars.
Yeah, exactly.
And then the second one is too.
R2D2. That's a small
silver
guy.
Box.
Yeah,
silver box robot character. Yeah. And I thought it was a very smart quote, because this C3PO, he's the protocol droid. He's designed to assist in etiquette translation, and he looks like a humanoid, right? And the other one, so the silver box, I call him, he repairs, and he has an ability to move in various ways, right? but he's not like a typical humanoid. And that's basically what she's saying. I thought it was a very
interesting
quote.
Yeah, absolutely.
Can I finish with one more, please? It's related to Winston Churchill.
Yeah, we can do that. Yeah, we can do that.
It's actually from Emmanuel Machtonka, and the original was done by Jeremy Utley. Now the quote is AI your tool, your co-worker, or your muse? And the thing with the tool that is related to Winston Churchill, it's got something to do with the beginning of World War II. I'm not going to get into that. But the point is, Emmanuel says, if AI is just a tool, it stays in the hands of the engineers. And we already talked about that a little bit. If it's a co-worker, you start redesigning how teams work, not just what they build. And that's what we just talked about already. You're going to have suddenly more, maybe, product managers, less engineers in relation. Doesn't mean. And then the final sentence is, he says, if it's a muse, you unlock new business models, not just cheaper delivery.
What what an ending.
Yeah, well, the ending is by Jeremy. I have to give it to him. Utley. He says, in answer to the question, if you're going to ask me how I use AI, I say I don't. I work with it. I think it's a very important one. I must say, very much looking forward to hearing from you, Robert, from you, dear listener.
Where do you find these conversations, Peter?
LinkedIn. I spent less time on LinkedIn.
Is there a philosophical AI discussion, or what is it?
But it is very important. I am very open to say that I've been saying for 10 years that AI is a tool. And I must say I'm opening up at least and seeing that maybe it's even more than a tool. So I'm not yet willing to say it's a companion or, but that's what these guys who are a lot more philosophical than I, and they look stronger maybe into the future than I, or at least I'm more willing to do so. And they say, yeah, you need to, if you open up and it's going to be your companion that sits on your notebook, whatever, on your smartphone, then things are going to be completely different. And yes, maybe that's not a bad finish for just before going into the summer holidays. Is it a tool, a co-worker, or your muse? A wonderful time I wish you, Robert.
Let's wait. Let's come back to the shop floor, because in the main part, we come back to the shop floor, and the Audi guys present a very cool AI project in the field of welding. And the partner was the Fraunhofer Institute in Stuttgart. And we recorded the episode, I think, 4 or 5 weeks ago. Very interesting approach, traditional machine learning, good old-fashioned AI project. I really liked it. Yeah.
Oh, good.
Yeah.
Robert, great. Have a wonderful holiday. Talk to you
Thanks.
again in a couple of weeks, I guess. Looking forward to. Have a great time.
Thanks, Peter. Bye-bye.
Thanks. Bye-bye.
Today, I have 3 guests. Professor Dr. Marco Huber from Fraunhofer IPA. Marco, welcome.
Yeah, having me again. Hello.
Yeah. Samira Dunagurst from Audi. Samira, welcome.
Thank you for having me.
And Matias Meyer from Audi. Matias, welcome.
Hello.
Most of our listeners are familiar with Marco, so I'd suggest that Samira and Matias will introduce themselves briefly. Samira, please start.
Yeah, hello. So thanks again for having me. My name is Samir Donagers. I'm a doctoral student at the University of Stuttgart and also at the Audi P Lab, the production lab. I'm also a student at the Graduate School of Excellence Advanced Manufacturing Engineering, and the topic of my research project is direct process control of manufacturing processes through real-time analysis, and it's evaluated on the resistance spot welding use case.
We are really looking forward to hear more. Matthias.
Hey, Matias here from Audi. I'm also at the production lab at Audi Neckarsulm, and I'm responsible for innovation and new technologies in the body shop.
Okay. Matthias, today we want to talk about resistance spot welding. Please explain briefly to all of us non-welding expert what this is.
resistant spot welding is the most common technology for in the body shop. We join their metal sheets together, and we have round about 5,000 to 6,000 spot welding points for one car body.
Okay. Wow. Can you give us a quick overview? Which plant are we talking about? What kind of vehicles? How many cars? How many welding pots and points on one day? Can you some facts, some numbers?
For sure. We talk about the A6 line in Neckarsulm, A6 and A5 line. We produce there around about 1,000 to 1,100 cars a day. So 5,000 to 6,000 spot welding points each car. So we talk about more than 5 million spot welding points for each day.
And what was your pain point with these welding spots?
We don't have really a pain point with our welding spots. We have to do a quality assurance at the spot welding for sure. We need to check them every day.
Because it's recommended by law, or is it a quality aspect at Audi, or can you go a little bit in details?
Both.
Okay.
Both, yeah. We destroy some cars. This is a must by law, to destroy cars and check the spot welding quality. And we do the quality assurance by ultrasonic. And this is what we do every day, every shift with a couple of people. They look for the spot welding points, not on each car, but on specific cars and specific points. And they don't have any guidance in their job. They have a guidance, but it's static. So they check every day the same spots, the same areas at the car. And we want to achieve not a static assurance, a dynamic assurance. What must be? We want to be efficient in our quality assurance. This was the point.
Okay, so Marco, when a customer like Audi approaches you with a task more dynamic, what does your evaluation process look like, and what specific requirements did Audi have for you?
Good questions. So the point is that, of course, most of the spot welds in such a car body shop are okay. I think more than 98, 99% of the spot welds do not have any issue at all. But this means that also the people which are doing the quality control with the ultrasonic device in the most of the time just check spot welds which do not have any issue. So meaning that 99% of the time it's more or less in quotes wasted, because effort is spent on spot welds which have no issue at all. And as Matias mentioned, one key idea is to say to really guide the quality guys to spot welds which might have an issue, so that their time and effort is more useful as possible. And of course, then we made assessment with Audi together, what kind of data is available.
It's a lot of data, right?
That's a lot of data. As Matias mentions, millions of spot welds per day are produced, and we are using really the data that is generated for each individual spot weld in order to then think about how to train a machine learning model. And of course, in such an environment, it's not only the question to train a model, it also needs to be deployed and needs to be capable of processing all the data. So it's also a question about how the IT infrastructure needs to look like.
We will talk about that later. Yeah, that's interesting. Samir, how did you and Matias now solve the problem? Let's take a look under the hood. What did you do in terms of technology? How did you proceed? Where did you encounter obstacles maybe in the project? Can you please go a little bit through the process?
Yeah, sure. So the main problem I'm looking at is the expulsion. It's a welding error which can occur during the welding, and it has many influencing factors. So first, let me explain you what an expulsion is. Expulsion happens when the melted material in the welding nugget escapes and squirts out of the welding zone, and it can adhere later to the vehicle components, to the welding system itself. So if it adheres to the welding system or to the robot, maintenance action is required because everything gets dirty and messy and has to be cleaned. And if it adheres to the vehicle component, it has to be manually removed because the expulsion residue, it's sharp and it can damage cables or workers can hurt themselves. And therefore, it has to be manually removed. And this is, of course, expensive and time consuming. So yeah, it's not critical for the spot weld itself because the spot weld is still a joint. It just, yeah, the problems I described earlier, therefore it has to be removed. And right now we do like in cases where a lot of expulsion, where a lot of expulsion happens, we are not really sure why it happens in that case because the influencing factors are so many. We cannot be sure if it's like from a malfunctioning system or if it's due to the process parameters or if it's due to glue from which is stuck at the spot weld. So the first step would be to establish like a condition monitoring for the welding system itself, but also for the process to make sure that the welding system is running smoothly, that there is no machine malfunction. Because if there would be a machine malfunction, the first step would be to do some maintenance action before we adapt any process settings. Yeah, so this is like a very important step to start with a condition monitoring system. So our idea was to monitor the process stability, to use the data we have available. And so we have one work where we compare different metrics to measure this process stability between a target state and an actual state. So we have the target resistance curve, how the process should look like. And this target resistance curve serves the PLC, the programmable logic controller, to as a process setting. And in an adaptive mode, the PLC tries to map that target state, the target resistance curve. And if the actual resistance curves strongly deviate from that target state, we say that there is a problem. And now we have a methodology where we check if the material is weldable. So do I have other welding systems in all of the production sites where I have the data? And do I have there a welding system where this material gets welded good or well? And if that's the case, I say, okay, this material is weldable and it cannot be due to the material. Then I check if my welding system has at least one good program, because usually a welding system has more program, let's say usually around 5 or sometimes even 10 programs. And if one of those programs performs well, we say that it's not the welding system which is at fault. But in cases where all the programs perform not good, we say, okay, this must be the welding system which needs maintenance action because the material is weldable and we have to check the welding system.
Okay. And can you tell us a little bit about the technology you are using? Because you mentioned there are different states, right? And they are connected, or am I wrong, to analyze the whole thing?
Well, actually, it's not really a model. It's just we're using basic techniques such as dynamic time warping or wavelet transform to measure the distance between the actual and the target state. So it's basically really easy techniques we're using, and most of the things we are using are really rule-based and easy to comprehend. And this also helps to work together with the production employees because they trust the system.
So this is the first step, or am I wrong? Or is it there's even more? Or can you please go ahead?
Okay, sure. Yeah, this is like a first step. So we have this condition monitoring for the process stability. And as I said, it's important to identify these malfunctioning systems because they lead to expulsion. And if we take maintenance action in time, we avoid expulsion. But of course, this is just one of the use cases. We also have different ones. We have one use case where we benchmark all of the process settings. So since we have the data from different production sites, we can use all the process settings and process data to compare the process settings. And in cases where we have a welding system where the process settings have a low performance, we can give the process expert a recommendation, and we could say, hey, look here in this production site, we have those process settings who perform much better with less expulsion. They have a shorter welding time. Why don't you try those on that welding system? Because it's the same material.
Marco, Samir mentioned there's no real model, but what is now our listeners, what is now the AI part? Because everybody thinks you need to have a model when it comes to AI.
Yeah, true. What Samir mentioned is really how to compare systems with each other. This can be done without any complicated AI model. So it's more like a data analysis part where we use metrics that are easily comprehensible, as Samir mentioned. But of course, if it comes to estimating whether a spot weld is okay or unokay, or if we do have some kind of expulsion, as Samir mentioned there, then machine learning kicks in. For instance, for this expulsion that Samir mentioned, which is something that should not happen, but sometimes happens. Sometimes means really seldom, less than 1% probably, but Samir has probably the correct numbers, but it's really a seldom event. But if it's happened, it needs to be resolved by some additional work, and that should of course be avoided. So the idea is really to predict when such kind of situation happens and what are the causes for this. And here machine learning is employed. So then we make use of these resistance curves that Samir mentioned, which is a time series curve, which has some hundreds of milliseconds of length. So this is how long the welding process itself takes. And this data is then processed by means of a machine learning model and can be used, for instance, to predict whether there is a expulsion or not, or other information can be predicted out of that. And here, we did, especially Samir, did a lot of work to analyze how this data needs to be pre-processed, because it's a high frequency time series. It cannot be processed directly as is, but instead there needs to be some feature engineering to be done. And based on these features, then several machine learning models have been tested, and it has turned out that, for instance, a LSTM model works pretty well.
Old one.
Classical one, I think now Sepp
1997.
Sepp is happy to hear probably that one of his classics is working pretty fine. But it turned out that LSTM is doing a very good job on that.
Can you explain briefly how it differs from other approaches, Samira?
I just have to open my paper because it's quite a long time ago that
Yeah, that's great. That's great.
Yes, we can share it.
Is it on archive? Can we share it after the recording?
Yeah, I think we could observe
Yeah,
that the
perfect.
paper or that the LSTM performed better, and we think that is because it can capture those temporal dependencies better, because a lot of expulsion happens always at the same position. This is due to, for instance, if there is a lot of a high gap between the sheets, for instance, we sometimes have that always at the same position. And I think this information is very important to say if the next spot weld will have an expulsion or not. And it's also important the information if the previous spot welds did have an expulsion or not. And we used the LSTM to predict the percentage of or the probability of expulsion for the next spot weld based on historic information from previous spot welds.
Mm-hmm. And how big is the model at the end? But you need to run it on the edge, so it should be a small model. Or am I wrong, Marco?
Yeah, it's not that big. So it's because the data is also not that complicated. We don't have to think about a huge transformer model or something like that. It's a rather small LSTM models. We also compared others like XGBoost, also some classic one, and Lasso, which was also good, but not as good as LSTMs. But in all the models we analyzed, rather small ones, as you said, at the end it needs to be run either on the edge or some limited cloud infrastructure, and has to be fast because the welding process itself is rather a fast process, and we have a cycle time which needs to be satisfied. So we can just not afford from a computational perspective to run a large model.
Samir, can you share some KPIs, or is it a Matias topic?
Yes, yeah, I can. So the accuracy of the LSTM was 95.41. The precision was 90.68. Recall 88.69, and F1 score was 89.68. And in all of those metrics, the LSTM outperformed the other methods or models.
So you built together with Marco, or it was your paper, it's your research, but you are not involved in bringing it on the edge, or am I wrong?
Not yet.
Okay.
Right now in the production, we mainly use those condition monitoring systems, and the expulsion prediction. It's not yet in the serious production.
Okay, so it's a test setting in the moment.
Exactly.
Okay, Marco, what did you learn from the project? What can other companies learn from the Audi project?
Yeah, there are many things to be learned. First is, and I guess Matias will talk to this later, is of course it's a problem where machine learning can really help, but it's just one, let's say, a puzzle piece of the entire puzzle. Even more important is really to get access to this data. And luckily, here the entire Audi company beforehand already put a lot of effort in their cloud infrastructure and the connection of their welding stations, that this data was available beforehand. You need to know, let's say, defective or NOK spot welds are really rare. So therefore, to have a sufficient amount of training data, that you have a sufficient number also of problems with the spot welds, like the expulsion, you really record a lot of data over a longer time frame. And if you start with this just by the beginning of a machine learning project, you will waste a lot of time just waiting to have a sufficient number of NOK spot welds. So there already Audi did beforehand a good job to have, let's say, the infrastructure in place that was capable of recording all the data. So data, and probably the common listeners to this podcast probably know that data is the key for this kind of projects. And the earlier to start, think about how to record them in a way that it's reproducible and it's not just for a POC, but really for production-ready AI, there needs to be spend some effort. Ideally, beforehand you start even thinking about building a machine learning model. So this is very important for all the companies who are thinking, okay, I need to do something with AI, but first there needs to be other things to be done.
Saria, you have this research paper, you did a fantastic job, but please share to our listeners, what were the main obstacles during your research?
You mean exactly on that paper or
on this project? Yeah.
On this project? Okay. Yeah, the main obstacle was because we have those arrays, the time series, like Marco said, the resistance curves, to fit them into our memory, because it is like even for one day we have 5 million spot welds, and to somehow fit those all this data in your memory, it is really challenging. And also, as Marco said, because this paper, I think I did it quite at the beginning of my PhD project, and we didn't have that data set which was already pre-processed. So we had to do a lot of pre-processing and understand the variables and what they mean. Like, this is still a huge challenge, which takes a lot of effort and time, and also correspondence with, for instance, Bosch, who provide the PLC and the software, to understand what each variable means and how it's sometimes calculated. And yeah.
What is on your agenda now, Samira?
My agenda. So right now I want to refine the methods we are already working with in the production. And for instance, the method I was talking about before, like the condition monitoring, we want to build a dashboard for that to allow all the production workers to use this dashboard in their daily working life, so they can identify malfunctioning machines fast. This is a main goal for this year. And maybe also check how we can bring the expulsion prediction model into the serious production.
Marco, what is from your perspective on the agenda now to bring it into serious production?
That of course is key to have it there, and I think we will learn a lot during this process, because currently, as Samia mentioned, we have it on some test stations to see it running. But of course, it will make a difference if we scale it to the hundreds of welding stations that are in a typical body shop.
That was my question. Is it capable to be transferred to? We have Audi, we have Porsche, we have Volkswagen.
I, of course, do not have all the details of the entire enterprise of the entire Volkswagen company, but I guess that like many of these welding stations, also from other car brands, they use this Bosch controller. So that's already simplifying the task of transferring the model. And also the welding equipment itself is oftentimes very similar to each other. So I'm quite optimistic that we can transfer it. What's important is that we have different kind of a combination of metals. It's called MTC, so the metal thickness combination, and therefore that makes more difference, I would say. You have to think about, is it really useful to have for each material combination an individual model, or might there be groups of combinations where one metal fits an entire group? This is something we have to think about when we really scale it up to an entire body shop.
So, Matias, how did you get now the model onto the edge? Can you please share the process? How do you do that?
Yeah, for sure. We developed a pipeline together with Siemens for the industrial edge environment we use at our use case, and we pushed the model from AWS, from our AWS account, directly to the shop floor on the edge PCs or something like that. Yeah.
Okay. And how difficult is it to do that?
Oh, it was really difficult. The discussion with our IT security department, with our IT department, to push something from the cloud directly to the shop floor. It's not easy. Let's say it like it is.
So you're running it completely on the shop floor, right?
We're running it completely on the shop floor, yes.
And the Siemens Industrial Edge or PLC is capable to do that?
Yes. We have a high performance PC.
Okay.
In the shop floor with NVIDIA GPUs, and can handle the model easily.
Can you give us an outlook what you are planning?
We're planning. I know if you heard something. I don't know if you heard something about our Edge Cloud for Production topic.
Yeah, exactly. I heard that. Yeah.
So we virtualize all the shop floor hardware, and this is also in planning that we virtualize this PC. We virtualize GPU, and we want to run it complete in our virtual environment, like the PLC future.
That means it's running next to the shop floor then?
Next to the shop floor, yes.
Okay, in a very big data center. And is it a pilot project, or is it already running, or what is the current situation?
It is already running. The pilot is done. We did it in Neckarsulm, and we are scaling it to our other plants in Ingolstadt, in Emden, in Wolfsburg, yes, in the whole Volkswagen group who's interested in such use cases.
But what about the model? Do you also share the model with your Volkswagen colleagues, or with your Porsche colleagues, or with your Lamborghini colleagues?
Yes, we share the model, and we developed it all in-house. It's all developed by Audi Data Science. We don't share our knowledge, but we share our model. Yeah.
Okay. Thank you very much, Marco. Thank you very much, Amira, and thank you very much, Matias, for this project. A really interesting approach. Thanks a lot.
Thank you as well.
Thank you.